in preparation for choosing the optimal cable choice for your end application. So I'm very, very familiar with it. I think one of the things that we have to do is, right off the bat in a 30-minute presentation here, I cannot give you a single path to the absolute correct cable. There is no flow chart, particularly as such, that will take you down to the single best cable that will meet all of the needs in your application. However, there are some questions that I can go through, kind of three main questions that I can expand upon, and then I'll also group what I see as a commonly presented list of priorities in cables that if you spend the time, whether you've got a specification or you're creating a specification, if you take the time to perhaps go through some of these things that I mentioned, I think it'll help make your cable selection, or at least expressing what you need in terms of cables, a lot easier once you reach out to the folks in Megahertz Marketing or you reach out through Teledyne Storm directly. It sometimes can seem like it's a fair bit of work up front and it's just a cable, and I really like to kind of just knock this out because I figured out every other part of my system and I got to get some things to hook, some cables to hook things up. But I think if we spend a little time assessing your needs up front and working through some questions, it's going to give you quicker answers and properly price and selected different types of cables. So to me, the very first question for optimal cable selection is, what do the cable assemblies need to do? Very first, what type of signal are we going to be passing through this cable? Initially, can you advise us whether it's an RF or a digital signal? Now that seems pretty straightforward. I'm going to guess that most of the people that are perhaps listening today are RF types, so that seems pretty obvious. But from my experience set, if I think about someone tells me RF versus digital, it sets a tone for the types of needs that you might be looking for. For example, an RF engineer, I expect the conversation to be speaking about VSWR and insertion loss of the cable and phase matching and some of those types of common terms that RF guys will speak of. If it's a digital application, the conversation is much the same, but some of the terminology and expectations change. We're going to be talking about return loss rather than VSWR, or we're going to be talking about delay and skew matching versus phase matching. And that's, yes, all kind of a mathematical relationship, but it makes us think differently about the type of signal that's going through the cable. I have combined listed here, not because there's a combined RF and digital, but occasionally there are some people that are trying to run RF and some DC power down the cable to power remote devices. And if that can be brought up front, that's helpful, because then we can make sure that we're not trying to run a whole bunch of current through a very tiny connector on the end. So if that's possible, if that situation comes up, let us know in advance. Connectors is certainly a very important part of this. It's connecting point A to point B, so certainly letting us know what style, SMA, TNC, or whatever. But even more importantly is what clarifying the sex of the connector, whether it's male, female, plug, jack. That gets omitted frequently, more so than you would expect, and sometimes is not done correctly. These two connectors I have here on the right, these two panel mounts, are, yes, bulkhead connectors, which for most standard types are considered jacks. But in this particular case, this connector on the left, it has a pin in the middle of it, so it would be considered a bulkhead mounted plug. This flange mount here on the right has a socket contact in the middle, so it would be considered a flange mount jack. Even if you tell us up front, this is what I'm looking for, unless you give us a specific part number, you just list it. On a lot of these connectors that have the reverse sex type pins on them, GPO, GPPO, SMP, that type of thing, we will very likely come back and ask or send a picture to you just to make sure that we're talking about the correct type of connector. The mounting of the connector, be it a bulkhead mount or a flange mount, as illustrated here, is also important. Everybody's trying to package in panel mounted connectors in fairly small spaces. So if you have an idea of what you're trying to do, what kind of spacing you're trying to encounter, that's valuable to share as soon as possible. The picture at the bottom here is meant to illustrate a very commonly asked question called, where can I start bending the cable behind the connector? Regardless of whether it's a straight or a right angle connector, typically everyone's trying to put cables in a location that they need to start bending the cable immediately because things are tight and they want to know what that is. So if you have a chance to think about that up front, have a little idea on the real estate where the cables are going to be, and if that height, as I have has illustrated to you, is of concern, that's really valuable up front because connectors, depending upon what cable they go on to, all have different mechanical lengths. And by the time we solder attach and we bend the cable, that height number can change fairly significantly. It was brought to my attention when I first created this slide that I'm showing Stormflex cable here, which is a very durable cable of ours, and it's got that black shrink sleeving that's behind the connector, which can be either used as a method to cover a solder joint, which customers typically want, but is also just visually looks like a strain relief. And for that type of product, Stormflex being a highly durable cable, it's really not necessary. However, it's the one that I have here as an illustration. The next point is frequency. It seems silly to bring up, but it is another big thing that does not get presented to us right away. What frequency are you using? Whether, and I realize many times that customers cannot express frequency due to classification situations, but if you can give us something in terms of a range or a frequency band that you're concerned about, or what maximum might be, that's really helpful, because not only does it help us determine other important outcome factors like the loss of the cable, but it also talks a little bit about the price of the assembly. A cable assembly that's operating at 1 gigahertz can be a very different price point and option set compared to a cable at 40 gigahertz. And also be aware that options for cables drop as your frequency rises. Many times a customer engineer will look up a cable in a data sheet set or our catalog and say, oh, I'm operating 15 gigahertz and this cable operates to 40. That's fine. That should work out real fine for me. Well, the lower your frequency is, the many more options that you need to, that we can provide to you and that you can consider. So don't look at the maximum frequency range of a cable and figure that it's really probably one of your best options. The next question really is simply, where do the cables need to go? And to me, that's just talking about if you can share the application in some manner to us up front, that helps clear the path for a fairly quick cable selection. I've listed these in terms of increasing order of complexity, starting off with prototypes. Prototypes to me mean I'm an engineer, I'm in a lab, I may be doing an engineering development model, I got to get something kind of thrown together, so give me a cable that's close, give me the cable with the right connectors, something that's going to pass the frequency, it's amplitude only, I'm not real worried about it. That to me is a fairly simple prototype. Or is it a prototype that says, no, yeah, it's a prototype, but I've got to have it look what the cable is going to be like when it's in the final system configuration. Those are both prototypes, but there's two flavors of prototypes there. Second one is lab environment. Is it general test? Is it going to be on the benchtop? I'm just hooking up a spectrum analyzer, or I'm going to a VNA, I'm going between pieces of equipment. Is it general test? Or is it going to have a little bit more of an environmental feel? typically it's going to go in a thermal chamber. And this is what we're going to do. We're going to go over some wide temperature ranges, and maybe we're going to go over a lot of wide temperature ranges several times, so lots and lots of cycles. Stepping up is, are we talking about a system cable? And if you advise whether it's aircraft or ground, if that's something that you can let us know up front, depending upon your ability to disclose things, just some of that simple, the two terms aircraft and ground gives me an idea of what your expectation set might be, and also prompts me for more questions to ask that maybe you don't bring up, because I've gone through many system cables in both of these environments, so there's a whole set of questions that just automatically drop into my brain. Last is space. This is going to be considered the most difficult. It's typically the harshest environment. So there's a whole lot of expectations to go along with this cable set. It's usually very specific design for cable, many times specific connector or alterations to connector design. And lastly, a much more complex either qualification or a data package that goes along with it. So asking you, what type of data do you want when we deliver these cables? Do you just want a test report, or all the way up to first article type things, qualifications, x-rays, the full 9 yards? So there's a wide array of expectations when it comes to space cables. Lastly, what do the cables need to withstand when they're doing it? And this goes in parallel to where they're going. Again, if it's that benign lab environment, that's pretty straightforward. It's a model. I'm not real worried about it. We're moving forward. But if we're moving into temperature, then we're going to want to find out how extreme of a temperature range we're talking. All of the Teledyne Storm cables that have been validated as we release them are certified over a temperature range of -55 to +125, meaning we go through all of the validation procedures for thermal shock, temperature ranges, phase stability over temperature. There's a wide array of reports that we can provide that gives you how the cable performs over that temperature range. Anything beyond that, now you're getting into some more extremes, which are going to have much bigger effects on the cable. So whether your cable may be cycling over those really wide ranges, or you're just going to get really, really hot, those are important points to talk about fairly early on. Weather, lots of stuff is outside, and really I have no difficulty with even our catalog products being out in a fairly standard wind, rain, snow, outside weather environment itself. However, is it going to get worse than that? How wet will it get, so to speak? Are we talking about a little bit of water coming at it, a lot of water coming at it, or even up to the point of where something could be submerged for some period of time? Whether you want to state that in terms of time and volume of water, some people are moving towards the IP standards to express that. That's valuable too, because we're going to consider making changes to the cable exterior to make sure that it's going to live through that environment and no disappointments. Chemicals is also very important. Not only a situation where maybe the jacket and marker sleeves and the connectors and so forth might be exposed to fuels and so forth, but even down to some fairly small things like, well, yeah, the connectors are all going to be mated, so things are in a fairly safe condition, but it is a fuel vapor environment, and we really don't want a silicone gasket in the interface. We want something more like Viton that's going to be better for that type of environment. Lastly is installation life. Is this something that's going to be just installed in a box, left alone? That's all that it has to be done with. That's one consideration for it. Next, is it a situation where it's going to be serviced, accessed periodically? Someone needs to touch it, someone needs to disconnect it, someone needs to deal with it periodically. that's another consideration, not only to maybe something we might want to do to protect the cable, like an armoring, or just from a standpoint of might want to specifically augment the cable in a different way. And abused is in there where we're really talking about an environment where it's going to get crushed, it's going to get pressed on, it's going to get bent overly tightly. I've got someone that's going to be handling it, whether it's a fielded Manpax cable or it's in a lab, and I've got people that are using the cables and they just don't treat them well. What can we do to try to augment the cable, give it some additional strength, and make sure that nothing gets damaged? So those are really the three, I'm going to call them the basic questions that you really need to run through to make sure that you have sort of the bases covered to get started. Here's an interesting picture that I had found for a cable, set of cables that were in a box that I had done for a customer many years ago. And this was originally routing from point A to point B and going through the panel there, as you can see, and then some cables going on up to some power dividers or some amplifiers that are sitting there. And lo and behold, it ended up becoming, well, no, this is something that needs to be accessed, and it is something that's going to have to be serviced. Well, then let's talk about how often. Who's doing it? Is it OEM manufacturers that are only going to be opening that panel, or is it field personnel? And if it's field personnel, what do they really need to do? Is it just opening to this amount that you see here, or is it something that's going to have to be open and closed many times? A choice of cable might change because of the frequency of how that happens. If it's being flexed a lot, we need to take that into consideration. If you can envision how that's going to be up front. Should we be considering something like service loops in the cable to make sure that nothing gets pinched? Should we consider some localized protection because things could be rubbing inside against other components? Many times I've had situations where I've done cables for boxes, and then I've had engineers come back and say, you know, we fielded this thing, and when we get at it, all kinds of stuff is rubbing. The cables aren't moving well. Is there a way that we can kind of provide some localized protection to make sure we're not replacing cables more often than we want to be? This 4 sets of groups are what I'm going to call the priorities that tend to come up during conversations, and they don't always necessarily come out early on. If they do, that's fantastic, but sometimes it's not a first mention item, and really I end up finding out that the customer says, I really have to have this more than some of my other requirements. I will give up some other attributes in order to make sure this is taken care of. And in the first upper left-hand corner here is loss. And certainly most customers are concerned about the loss of the cable based on length and frequency. They want to make sure that it's going to take care of what they need it to do. But I've had some customers say, look, no, I really need absolutely the lowest loss. I'm running a fairly long length between 2 points. I've got to have as low as loss as I can get. So I'm really willing to get perhaps the largest cable that I can to fit the connectors. Or I've gone to your website and I took a look at the DB Miser series, and based on that name, and I think that I've been told by the system guys that I really need to make sure that I minimize loss, I'm considering the DB Miser cable. So it is absolutely a priority of mine. Going hand in hand with that is maximum power handling. Maybe you're not thinking necessarily about low loss, but if it is a continuous power type situation where I'm going to be concerned about the cable becoming heated, solder joints getting warm, something like that, certainly the very lowest loss cable there is going to help us minimize signal being turned into heat, and we're maximizing the power out coming from the second end. I listed pulse here kind of as an ancillary thing just because I think it is our priority, but that's not really so much of a loss situation to me. Is the cable going to be able to handle the high voltage pulse that happens? And so we're really looking at the cable a little bit differently from from a high voltage standpoint, not only the cable, the connector, but the transition into the connector. Upper right-hand corner is flexibility. That really is described as a whole bunch of situations, whether it's an ease of the cable being installed into a very tight space, such as, some of our very smallest cables, Stormplex 047, something like that. People are within a small confined area, and we've got a plug-in connectors, and we've got a router on inside of a box. I got to get it in there. I can't have a small cable that's too stiff, that will not get me from point A to B. It can't be too hard to install. That's a big concern. Or is it a situation where it's truly about maybe flex force? It is a larger cable, like in our FlexCore series, where you're concerned about something that has low flex force. Ideally, a cable is part of a system that's moving. Maybe there's a gimbal mount that's motorized and things are moving and we can't load the motor down too much. So I'm very concerned about what type of flex force, which actually gets expressed as Tabor units in some of our documentation, how well is that going to be? The other part of flex force really is perception too. I think a lot of times if it's a benchtop application and someone is just interested in a test cable and they want low flex force because they're working with a device under test on a benchtop, and they don't want a stiff cable that's going to push the device under test around and make it difficult to work with. So even something like that is just a perception of how the cable feels, and I think that's important. Lastly is flex life. This is something that's going to be moving a lot. It's either in a remote area and it's part of something that gets moved all the time, or it moves enough and the location is such as we can't get back to replace it periodically. Maybe it's out at a remote site. So high flex life is a big deal. And when I say high flex life, it's a situation where I'm speaking of 100,000 flexures or more, up in that territory, where we're looking at cables with stranded center conductors that allow you that high flex life. So that's a very important consideration. The bottom half of the slide is where we're starting to talk about electrical length of the cable and your concerns over the electrical length of the cable. The electrical length, whether you want to call it phase, you want to call it delay, however you choose to express it. The first situation is here on the left where you're saying to me, I'm concerned about the cable. What kind of electrical length matching can you provide to me on an as-delivered basis as we ship the cables to you? Do the cables need to be either phase or delay matched? And if you do know some type of a tolerance that you're looking for that you need to express to us that maintains your system requirements, that's fantastic if you let us know. Some number of degrees at a frequency, or if you really don't know, you can say to us what do you folks recommend as a very reasonable starting point that delivers well-matched assemblies, but it's not getting into the area where the match becomes so tough that we're worried about scrapping cables out because the match just doesn't get accomplished as we terminate the connectors. A very good rule of thumb that I like to pass along that maybe makes it easy for people is a tolerance of plus or minus 1/2 degree per gigahertz. So if you are operating at 10 gigahertz and you are looking for a relative matched set of cables, you could say, plus or minus 5 degrees at 10 gigahertz is a very standard point that we would offer as a good balance between what Teledyne Storm can accomplish very readily with our production processes, but yet we're not going down below that point where the costs are going to start to escalate. That's a frequent question. What can you folks do? What can I get that is really reasonable but doesn't break the bank? The other way to express it, if you're a digital folks, I would say plus or minus 2 picoseconds. So that's really about equivalent to 1/2 degree per gigahertz. Good rules of thumb. I think it works well as a starting point for a discussion. The lower right-hand portion of the slide here is talking now about after the cables are delivered to you, I am now concerned about what the electrical length stability is once the cables are in their application and use. So are we talking about something that's over temperature? You're going to be in a system or a test environment where things are going to go beyond ambient temperature ranges. We're going to be moving up and down several times. I'm concerned about the electrical length change. And the two very distinct differences when we're in this category of concern over temperature is your concern about the change, electrical length change of any one cable in your group of cables? I can't have it change more than X number of degrees or X number of pico or nanoseconds. I can't have that. Or is the situation such that I have this group of cables and they're matched to each other? That's fine, as long as they all track each other as we go over temperature. I really don't care what the absolute shift is. Tracking is more important to me. Those two differences are significant and alter the discussion and end outcome of cable choice by a significant difference. The last bullet point is electrical length stability over flexure. To me, certainly that's either A, how much change is going to happen because I'm in a benchtop environment. I want to be able to move these cables around, and I can't have the number of degrees of shift be too high, otherwise I lose a calibration, or something in terms of like, I'm going to unwrap a long cable that you've delivered from us, and I'm going to install it in a system. So I really want to make sure that I'm not going to lose phase match once I go into a certain installation situation. That one's a little tougher to quantify. If it's in your benchtop and we're talking about a fairly straightforward flexure situation, pretty easy to quantify because the type of bending goes on is pretty predictable. Unwrapping a 50-foot cable and bending it here, and each one bends a little bit differently, is a little bit longer of a discussion. But it is worth discussing early on if you can. The next set of information that I think is important, now that we've kind of gotten past basic questions and priorities, I'm calling them Sidestreet frequently asked questions. A lot of people say to me, hey, what about semi-rigid, or what about flexible cable? How do I decide what to use? And obviously, if your cable needs to be flexible, it's in a flexing situation, or I'm installing it as such, and it's just not possible to use semi-rigid, then obviously the discussion ends there. But a lot of times, semi-rigid cable has some very nice attributes to it in terms of packaging, absolutely minimizing loss for the cable size, very precise routing. There's some real advantages to that. But as time has gone on, and I would say certainly like within the last 10, 20 years plus, in the early days, semi-rigid was one of the historical choices of transmission line versus a flex cable, and flex cables weren't really quite as capable. But now I would say really the choice of semi-rigid is predominantly cultural choice by the end user. I'm assuming there are a number of folks here from Northrop Grumman, Baltimore, who use semi-rigid cable extensively. It's part of their engineering culture. They're very familiar with how to route the cables and actually do the design work such that it's manufacturable. Manufacturable means is that are the bend radii along the length of the cable consistent enough that we can use automated equipment and we can keep costs down. So semi-rigid cable, you really have to want to use it. If it works for you, fine. But if your company is not really oriented that way, I think it can really slow the options for you and not necessarily give you the best outcome. The second big issue that is huge, huge, huge is marking. I would say of one of the biggest issues that I face in discussions is about marking the cables. If a cable is good size, 200 thousandths or larger that I picked, that's a pretty big cable. It's going to allow almost any type of marking text. There's usually ample length and circumference around the cable to be able to put in multiple lines of text. So I'm not particularly concerned about that. The issue becomes with marking is that once you get down to smaller cables, let's say about 100 thousandths and smaller, you really start fighting the real estate. Those cables tend to be pretty short, 6-inch cables, 4-inch cables, 8-inch, something that's down in the short length. And people really want to start putting a lot of information on it. Not only markers at each end pointing to, where's the cable coming from, where's it going to, but a center marker that's listing the part number and a serial number and a lot code, date code, and several lines of information. When you're getting down real small, it's difficult to mark all that information on there. A good rule of thumb to try to think about this up front is use about 100 thousandths of length per text character or space. So if you think you've got a print on a small cable about 10 characters in a row, you're going to need about a 1-inch long marker. And you would be very surprised how I get markers of 15 characters or more, and people want to do it in 1/2 inch to 3/4 of an inch. So if you're looking at short cables, is it something that you could consider putting the minimal amount of marking on it, maybe just the ends, and putting the remaining information on the bag tag? That, I think, works out a lot. You're not, in general, you're providing the information needed for the end installation, and you're not covering up a cable with all kinds of shrink tubing, which ultimately, as a flex cable, is going to reduce its flexibility when you're trying to install it. Last bullet point here is what kind of test report formats are there? What do you typically do? Historically, most cables leave our facility with what we call a tabular test report. You got 10 cables listed on it. There's 10 values of maximum insertion loss, maximum VSWR, maybe phase offset if you bought phase match cables. That kind of data is there. A step up from that is what we call a swept frequency chart. So you're actually seeing a graphical representation of what the loss, what the VSWR, what the phase looks like. And then that way it's a little nicer for you to be able to get an idea, maybe pick a point off that chart where your application is working. A further step up from that is what we call an S2P file. Those are becoming much, much more common, and that gives you the raw vector data of the cable assembly performance as you are like looking at it on a network analyzer. So you can take that S2P file, you can import it either into your programming that you're using or an Excel file, and then you can manipulate that data as you see fit. I'm starting to see a great increase in the requests for that data. Lastly is some custom reporting that you might be interested in. VSWR, phase, loss, those types of things are very common, but if you're going to get into a situation where you want something a little bit different, let's say fine grain insertion loss ripple or some variability on that, we can do that for you. We can either do some custom programming. We've had some situations where customers have their own programming and they've provided a laptop, and we can do specific measurements for them. So in coming to the conclusion of this, my situation is I typically talk to engineers. I find that the mechanical engineer is typically the one that's in charge of the coaxes. They've got to put everything in the box. They've got to decide what fits, make sure it's not too heavy, all the right connections and so forth. And there's a feedback loop that goes back to the electrical system guys who are typically saying that's fine, but whatever you need to do, but I got to maintain my loss budget, or just make sure I don't get too much reflection in the system, and let's go back and forth with it. So I really find, and I think the guys at Megahertz would agree, that there's always ending up, that the end optimal cable of choice ends up being the balance that really makes both of those end users happy as best we can and works in the final situation. If you've made a cable selection choice from our website or something, and you come in with a choice, if you think you know for sure that that's what it is, that's fine if you have a lot of experience with it. However, if you think that it might be a guess, let us know. Hey, I've chose your phase master cable because I'm concerned about phase in my system, but I'm not 100% sure if that's the right one. So, help provide some guidance and make sure that between the two of us, we make sure that we get you the correct choice for your need. And with that, I will say thank you for listening to me for a half hour or so. I hope these points have been valuable. And at that point now, I'd be happy to entertain any questions.